Good morning. It's Miss Murphy. We're going to look at acceleration by way of a graph. So we're going to actually look at speed versus time graphs. Last we had looked at distance versus time. Today we're going to look at speed versus time. Okay. I'm going to share my screen. So please pause or bear with me. Be patient. Thank you. Share. Not now. Oh, beautiful. Add new. Awesome. Okay, so let's give ourselves a title here, team. Okay. 1.6 speed or velocity. Okay, so we're going to look at speed versus time graphs and how they can give us insight into acceleration. Okay. Remember that acceleration, this is a review, equals change in speed or velocity over time. And we had learned to simplify that with this equation here. All right. We also learned that this would be in meters per second. This would be in per second. And this would be in meters per second squared. Okay. All right. So here's the quick rundown. On the y-axis, we will have speed. On the x-axis, we will have time. Okay, we'll put a 0 speed, 0 time. This will be in seconds. This will be in meters per second. All right, so what I want you, let's put some lines on this graph. All right, we'll start here and then do this 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 and then do this. Okay, I'm going to extend this x-axis. I'll actually put some numbers on here: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 4, 26, 28, 30, 32, 34, 36, 38, 40, 32, 46, 48, 50. All right. And I'm just going to go, let's see, 10, 20, 30, 40, 50, 60, 70, 80. Notice I'm not really worrying too much, right? Okay, let's look at what's going on. Notice right here, we have speed, okay? So these numbers represent our speeds in meters per second. Notice down on the, hold on, let me get a different color here. Notice down here we have time in seconds. So these numbers represent our time in seconds. So what we can see is that between 0 seconds and 8 seconds, this is our line. So notice that our speed during this part of our graph between 0 seconds, oops, let's undo that, right? Between 0 seconds and 8 seconds, the speed equals what? Well, it equals 0 meters per second. So we see that right here, we are not moving. That is because our speed is 0 meters per second. All right. If we look at time 8 seconds to say 12 seconds, right? That's referenced in this line of our graph, right? That's your 8 to 12 seconds there. And we see that we are actually speeding up, right? Notice our speed is over here on the y-axis. And we see that as that time is passing, we are speeding up, all right? So we are speeding up. It looks like we are speeding up at a constant rate. Okay, because that line is straight. Okay, now let's go back and look at our graph and let's see what's happening during this and this time, which references, let's see what time on the graph that is. That would be 12 seconds to, I guess that would be about 23 seconds. So we'll write that down from 23 seconds. Nope, sorry, 12. From 12 seconds to 23 seconds. And once again, this is the pink part of our graph, okay? Let's go ahead and put this yellow, this orange was the orange part of our graph. Well, what are we doing? Between 12 seconds and 23 seconds, I'm moving right here. Well, it looks like I'm moving because my speed's not 0. In fact, my speed is a little under 40 meters per second. So it looks like at this time I have a constant speed, right? Oops. I'm going to move that. Put that right here. I have a constant speed. And that is a speed of about 38 meters per second. Okay. Okay. Now we have another line on our graph. I'll put it in blue. We're going from here to here. Notice that is about 23 seconds to, let's just say 28 seconds, all right? So we're at 23 seconds to 28 seconds. And that's what we see once again in the blue line of our graph, okay? Let me clean this up a little bit. Okay. Sorry, team. All right. So between 23 and 28 seconds, what is happening to our speed? Well, if we look, it looks like we're moving up. And on the y-axis, that's speed. So we see once again, we are speeding up. Right? And then if we look at the next section on our graph, let's go yellow right here. Right? That would be between what seconds? Let's look down on the x-axis, about 26 to say 32. Well, let's just go from 28 seconds to 32 seconds. Let's make that yellow. And look at what we're doing. What are we doing from here to here? This looks like we are slowing down. Okay. And then we look at the next part of our graph and we see once again that we have a straight line. That line is straight across our speed. So what are we doing? We have a constant speed. Right? And then we have one more line on our graph. Hopefully you already know what we're going to say about that. It has a negative slope. So we are slowing down. Okay. So you should have a good idea of what's going on there. Once again, we've got speed on the y-axis and time on the x-axis. If we look at that one more time, time on the x, speed on the y, we see we are constant speed, speeding up, constant speed, slowing down all the way to a stop because that's 0 meters per second. We are stopping, going forward, but actually we're not going forward, we're speeding up, same speed, slowing down, same speed, speeding up, right? Let's identify that one more time. Constant speed, faster, constant speed, slower, faster, constant. What's constant? Speed, slower, constant. Remember, constant means not speeding up or not slowing down. Faster, speeding up. All right. Now, the last thing you need to be able to do is to use this graph to calculate your acceleration. All right. So let's just go 0 meters per second, 0 seconds. This will be our speed. This will be our time. Let's put 10 meters per second, 20 meters per second, 30 meters per second, 40 meters per second, 50 meters per second, 60 meters per second. Oops, I don't need to put that there because I've got it here, meters per second. All right, then down here, let's just do 2, 4, 6, 8, 10, 12. Okay, let's go from here to here. So there's our constant. We have a constant, oops, or we're speeding up at a constant rate, okay? Speeding up at constant rate. And then what we want to say is, what is the acceleration, right? If we're speeding up, we're accelerating. What is the acceleration, right? What is the numerical value for the acceleration of the object? Well, notice that acceleration equals change in velocity or change in speed over time. Once again, the change in speed is on the y-axis, right? So this is actually your, oops, we've seen this before. This is your y2 minus y1. And then the time, time down here is actually on the x-axis. So we'll put x2 minus x1. So just the other graph gave us speed. This graph actually gives us acceleration because that will be the change in speed over time. Right, so that will equal the slope. One more time. So the slope equals the acceleration for a speed versus time graph. Okay. All right, so let's get the slope of our line. I'll clean up my screen and we will be done with this video. A little bit longer than I wanted it to be. And I apologize. It's making a mess of me. Stop. Okay. Zoom back in and let's just get our acceleration. Equals y2 minus y1 over x2 minus x1. So we'll go to our line and we will get some good points on it. Let's see. let's go 30. Okay, so this here team is Y2. This here team is Y1. This down here team is X2. And this down here team is X1. All right, I'm going to change my color. I'll do red. Y2. Y2 is 30. So that's 30 meters per second minus Y1. Y1 is 0. 0 meters per second over my time. X2 down here, 6 seconds minus X1 down here, 0 seconds. All right. And now we've done all the hard work. This eraser is not my friend. Okay. So what is 30 minus 0? That's 30. What is meters per second minus meters per second? Meters per second. Over. What is 6 minus 0? 6 seconds minus a second is a second. Now 30 divided by 6 is 5. And a meters per. And then we have 2 seconds on the bottom. So that is the unit for acceleration. So that, according to our graph, is our acceleration. Notice it's positive. Oops, because we're moving faster. If it was negative, sorry, I'm frozen. And if it was negative, there we go. We'd be slowing down. A little messy, trying to move fast, but I think if you just watch over it, you'll get the gist of it. My pleasure, team. I'll see you soon.